Hello, and welcome to this exploration of AC sine waves and their importance in the world of electrical engineering. Alternating current, or AC, is a fundamental concept in electrical engineering, and its representation through sine waves is crucial for understanding electrical systems. Let's begin by understanding how a sine wave is formed. A sine wave is a smooth, periodic oscillation that describes a repetitive wave-like pattern seen in the figure on screen. To help visualize, imagine a point moving in a circular path at a constant speed. The projection of its circular motion onto a straight line on the y-axis will trace a sine wave. In electrical terms, a sine wave is formed through the variation of voltage or current with respect to time. In an AC circuit, the voltage and current change direction and magnitude following the sinusoidal pattern. So how exactly is a sine wave generated? The sine wave is generated by a rotating coil in a magnetic field to continuously provide alternating voltage and current. As the conductor rotates through the magnetic field, it moves through flux lines at different angles, inducing current. This will be further explained on the next slide. The graph on the right helps visualize how moving through these flux lines at different angles generates different values. The greatest value occurs when the conductor is at right angles with the magnetic field, at 90 and 270 degrees. As it continues to rotate past the points of perpendicular, the current decreases until it moves to be parallel to the field, at which the current 0 at 180 and 0/360 degrees. During one cycle of the sine wave, it moves perpendicular and parallel twice. Let's delve into how we analyze sine waves in electrical circuits. Sine waves can be represented by the following function. V as a function of t is equal to a sine bracket omega t plus theta, where a is the amplitude, omega is 2 times pi times f, f is equal to the frequency measured in hertz, t is equal to time measured in seconds, and theta is the phase angle. Reading off the graph now, the phase angle describes the shift in the wave along the horizontal axis relative to a reference point. The amplitude represents the peak value of the wave. The frequency is the number of cycles per second, where a cycle is denoted as 2 pi. AC sine waves are analysed through key parameters: peak, instantaneous, and RMS values. The peak value represents the highest point in the waveform. The RMS, root mean square value, is the square root of the average of all the squares of all the values in one cycle. It's crucial in AC analysis as it provides an effective way to compare AC to DC, offering an equivalent value that simplifies calculations, found by using the peak value multiplied by 70.7%. Lastly, the instantaneous values indicate the value of the sine wave at any given moment, calculated using the peak value multiplied by the sine of an angle on the graph. Thank you for watching.